All right, guys, we're back and we're moving on to some cool new features in Tableau, extensions and APIs. And first up, we've got Matthew Miller, who's going to be talking about aggressive pre-caching to get FAST fast. Over to you, Matthew.
Brilliant. Thank you. Awesome. Anyone has any questions, by the way, as we go, we can keep this somewhat interactive. Feel free to ask questions in the Q&A panel. So, yeah, this is a website. And did it load pretty fast for you? How long did that take to load? Probably like no time at all, instantaneous. Did it take 15 seconds with a little spinning circle? Did it take 30 seconds, 5 minutes, 10 seconds? No, it was instantaneous. Just poof, appeared on your screen. There were no queries to run. There was no computing layout or table calculations. It just loaded instantaneously. And that's awesome. That's what we're used to on websites. And in fact, on the BizStory website, I mean, no matter how good our content is, no matter how well we design it, how long will people wait to look at it? I've heard 7 seconds, but I've actually heard that web users have gotten more impatient, less patient over time, and now it's like 5 seconds or less, and they just click away. And you're probably thinking to yourself, this is a website. Why are we talking about websites? Isn't this a session on Tableau Server? But bear with me, because I think that this analogy or metaphor will help us understand how web technologies have solved performance problems for websites and how we can do the same for our Tableau dashboards. But first, my name is Matthew Miller. I'm part of BizStory, one of the European Tableau partners, and a shout out to all the BizStory people who I know are gathered in a conference room watching this. Hi, everybody. We're going to talk about hyper-caching at the edge of reason, aggressive pre-caching to get your dashboards to load, F-A-S-T. But first, a little bit of history. For those of you with gray hairs like I have, who remember the dial-up era, things were different then. So let's start with how it all worked back in the day. Life was simple. You would browse to a website, and you'd get a bunch of static files immediately downloaded to you. There were no queries, there were no waiting, there was no computing layout, there were no table calculations. It just worked. It was a simpler time. These were happy days. We had dank memes, but they're all made in ASCII. And those were good days. And then the world moved on, and it got more complicated, and displaying a website took some queries. Websites got slower, and we added these technologies in between the files and the user to do things dynamically. So things like Perl and PHP, and again, if you're as old as me, you probably wrote some CGI bin stuff, and there were a bunch of other technologies that did this. And basically what would happen then is you'd go to browse to some website, and the server would go, what are we doing? And PHP would go, well, we're making a website. The server would go, awesome. What's it look like? What should I tell the laptop that's waiting on this page? Well, hang on a minute, PHP would say. I'm going to go execute some queries, and then we'll find out what the web page looks like, and I'll then respond, and then you can stream that back to the end user. And so we got a lot more flexibility. Now things were dynamic. We could use some kind of drag and drop higher level web page building tools like WordPress or whatever. But things also got slower because now there were a whole lot more complicated steps that went into rendering web page. This right here is what's known as the loop. It's kind of the core of how WordPress works as an example. And there's all these different pieces that go into an individual web page. There's a header, there's a sidebar, there's a footer, there's blogs. And this or something similar is what happens when you view pretty much any web page without caching involved. It goes off and says, okay, I got like 10 components here. I got to fire off 15 queries. I'm going to put all these pieces together, and I'm going to stream them back out to you, the unsuspecting user. This is basically how all web application technologies work. And it's not really all that much different then from what our good friend Tableau does. This is Tableau Server, and as you probably recognize it, it's just got that Tableau look and that Superstore feel. So Tableau dashboards do the same thing. I feel like when you first access a dashboard, Tableau goes, hey, what are we doing today? And then it goes, oh yeah, we're making a test. That's right, we're making a dashboard. Great, what's it look like? Hold on, I got to run some queries. And then it goes off to the repository and it extracts the blob that contains your big XML file, and it parses it, and it goes, oh man, what's this thing made up of? Oh, it's got, see, 1, 2, 3, 4 visualizations. Where do they come from? Oh, they come from some data. Where is that data? I don't know. Let's go figure out what queries we have to make through this VizQL layer. And then off it goes, fires the queries. And when all that stuff comes back, then there's in-memory stuff and computing layout. And you guys all know the order of operations. Or if you don't, there are a million vizzes and blog posts about it. We've got one as well. So then finally it gets that done and can stream the dashboard back to the user who is sitting there bored, has gone and gotten a cup of tea by then, or just closed it and said, forget it, I'll go get my insights from Excel like I used to. So that's not cool. A good friend of mine works for CNN as a webmaster, and he was telling me how CNN, which is one of the top most visited websites in the world, handles this problem. So they have a dynamic content management system, kind of like how we use Tableau to drag and drop and define what we want. They have a dynamic system. So if like there's a big breaking headline news, Trump impeached, just for example, and they want to run that, they don't go edit HTML files by hand. They go into their content management system and they type Mueller finally victorious or whatever, and they hit submit, and that goes off into a database, sure. But then their content management system goes and pre-renders and pre-caches every page as if it were static HTML, and that way it always loads instantaneously, even though a page like the one you're looking at here is very complex and it requires a whole lot of different database queries to assemble. They all do that behind the scenes, so when we access it, it's instantaneous, which is pretty clever and pretty awesome. Just want to see if there's any questions. I see there's a chat. Someone has caught the Homestar reference. I love that. That tells me literally exactly what age you are. All right, so that's all clear. Now let's take that to the Tableau world. And Tableau dashboards, as I mentioned, do the same thing. They go, hey, what are we doing today? Oh, we're making a dashboard. And then they go off and figure out what queries have to be made. Now, for those of you who are studying for the Tableau Server Certified Professional exam, you may want to pay attention to this bit. When you go and access a dashboard that's not cached, there's a whole bunch of stuff that gets involved. Of course, everything goes through the gateway, and then the Viz portal gets involved to check permissions and whatnot. And then the VizQL server takes over, loads your workbook from the repository, and then figures out, okay, what is this thing? It's a sheet, it's a dashboard, it's a story. Okay, what's in it? It's got a dashboard. And it goes through this, and it feels like a Tableau every morning when you access your dashboards for the first time is like waking up, like in Memento, going, what do I do again? Oh, I make that's right, I make dashboards, as if it's never seen this dashboard before and never seen this data before. It's almost maddening, isn't it? So I've kind of color-coded here what's good and what's bad. Worst case, right, is that we go live to the database. Almost always that's going to be the slowest. And I'm talking mostly here about queries. I'll talk a little bit about design later, but the queries, as we know, are the big thing that can drive performance through the roof and to the point that our end users lose their minds or go back to Excel. So the worst case is that we just have no caching. We're not even using hyper or extract. So we have to go to the database for every query. And you know, Tableau's really chatty. Tableau is just that super extroverted person at the bar who will not shut up. And Tableau is like that toward databases, just sends up many, 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 many queries. And so it's going to fire all those off down through the drivers. Of course, you can only do so many in parallel. You guys know these things. And finally gets back the data that it needs and then goes and renders. And mercifully, after that first query, that abstract result that comes back, so the aggregated results, not the raw stuff, goes into the cache server, that bit there in green, so that subsequent loads don't have to fire those queries. Now, we know that you can use extracts to speed things up. You can use hyper. Of course, hyper is better than almost everything else that's out there in terms of database performance, but you're still firing queries. There's still some latency, and it still can be the case, especially with a lot of string comparisons or really wide tables, that hyper also isn't all that fast in responding to queries. I've seen hyper queries that take multiple seconds to respond. So there's got to be a better way. And we know that the cache server can serve things out of memory, or at least you'll see in subsequent slides that it can. So if we could get everything into the cache server ahead of time, we would eliminate those queries to any database, to hyper or live connections. So that's pretty awesome. And those query results go into the cache server. So again, in our previous example of that dashboard where we had 4 sheets, we're looking at a minimum of 4 queries being generated. Wouldn't it be great if the answers to those queries were already sitting there in memory on the server? Now this right here is an example of an ugly dashboard. It's built in Power BI. And I just wanted to illustrate that achieving great performance, we should say as a sidebar, is not just about technical things. It's certainly not just about caching. Often the best way to improve performance is to rethink your design. Your dashboard is slow. It's not me, it's you. It's not you, it's me. No, sometimes it's just the design is the problem. And sometimes the best way to improve it is to rethink your design or to optimize your queries. So what we're talking about here is none of that. We're not talking about design best practice or optimizing performance from a Tableau perspective. We are talking, let's be honest, about band-aiding performance through aggressive pre-caching. So this is not the solution I lead with when customers talk about performance, but it is sometimes the approach that makes the most sense. I mean, a dashboard like this will probably fire off more than a dozen queries. If it were in Tableau, for sure, that's more like 20 queries or more. And we want to cut those down as much as possible. I do have to credit our friends at Questback for the inspiration to look into all of this, because we had toyed with different approaches to pre-caching. And then they called and said, hey, we have a thing happening where we're going to have 20,000 users accessing 7 dashboards all in one day. And so that's fine. The first person to hit that will, cache everything. It'll be okay. They said, no, it's got row level security. Okay. And they said, what do you suggest? And that got us going down this path of how can we make sure that there are no queries fired whatsoever? Because the fastest query is no query at all. So we started looking into what was possible to make sure that we never fired any queries in the rendering of those dashboards. So coming back now to our diagram, we created this thing which we call the hypercacher, and it goes in to the application server through the REST API. I guess technically I should point out it does actually hit the gateway, but it talks to the application server through the REST API and runs through the process of populating the cache server with all possible query results so that all dashboards render as quickly as possible. And what I'm going to show you is the logic behind that, so you can build this kind of solution yourself, how we did this through the REST API, and I'll even give you a little demo of what we've done and talk about some of the things you'd have to factor in if you're implementing a similar kind of solution. I have actually built something like this for a customer in Alteryx. I know that was the tool that Carl did not want to name earlier, but it is possible to build something like this in almost any kind of language as long as you can communicate with a REST API. So our goal here is to get that thing, the cache server, full ahead of time with all the query results we could possibly need. Some of you may be asking, though, what is the cache server? So let's talk a little bit about the cache server component before we talk about how to spam it into next year with the hypercacher. So the cache server is an open source component called Redis, and you can go and read its documentation. It's widely available. Its source code is open. And Tableau, as they have done with a number of components on the Tableau server, of taking something that was open source, packaged it into Tableau, and charged us by user for it, which is fantastic. Just kidding. We're paying for the proprietary stuff, I'm sure. And that's Redis. And it's this cache server that provides a key value store that's stored in memory. You can have multiple instances of it spread across your cluster, and it stores those query results so that they can be reused by the VizQL, the rendering processes. So in other words, it's a non-volatile caching service. The cool thing about Redis is that you can restart your server and those cache entries are still there. And they have a default lifetime of 12 hours. So that means that the first person to come in the morning and look at the dashboard can basically warm the cache for the rest of us so that everybody else gets fast results. Now, Redis is the cache server instance, as I mentioned, and you can find out where it is on your server by going to your system status view on the Tableau server through the UI, and you'll see it there as cache server. If you hover over it, you can actually see which port it has been assigned, which we will need later. And then we will use that to actually interrogate that and find out what's going on in the cache server. Some things you may want to write down. If you want to get that password to authenticate to it, it requires an authentication key. You use TSM, and you go TSM configuration get redis.password. That's going to give you this big, long, hex-looking string that is your authentication key. If you'd like to get the port for your Redis instances, you can get them either from the system status window that I just showed you, or from the venerable admin system info XML. Moving on. So how do we actually access this? There is a command line interface for Redis. So for those of you who grew up in the iPad era, multi-touch, this will be completely over your heads. You may go back to Snapchatting if you like. But for the rest of you who are interested, you can use a command line interface to connect to Redis using the command that's here. You give a Redis CLI. It is installed in the Redis folder, deep in the Tableau installation under packages now in the TSM era. You can find it. I didn't include a path to it, but anyway, and also its path depends on where you install Tableau server. So go find the Redis CLI, and then you give it a host to connect to. Now, if you're using a cluster, you'll need to give it the host name or the IP of the node in your cluster you want to connect to, and then give it the port of the cache server instance. Again, it's typical, very common to have multiple cache server instances, so you can connect to them individually, but they all will use the same authentication key. Then you put AUTH for auth and your key and get yourself connected. Then if you want to clean up this cache, you actually can do all that through the Redis CLI. There are commands to dump the cache manually. And Tableau exposes this too with a command called tsm maintenance cleanup-r. The maintenance cleanup can also clear up logs and temp files and so on, but the -r option goes and dumps the contents of the Redis cache. Okay, again, if you have any questions, feel free to holler, chat panel, Q&A. So that's a little bit about the cache server. You can find out more. Here's an example of the admin system info view. It used to be that the ports were predictable, but Tableau in their infinite wisdom have gone to a world of completely dynamic ports. You can shut that off with some configuration options. There's a help article about it. Or you can do this route of curling this system info file and parsing it to grab your current cache server ports. They can change on restart. There's one question. Is it okay with the license agreement if we connect to Redis? I don't know that there's anything that connecting to Redis does to violate the EULA of Tableau. The Redis is an open source product, and I mean, they support connecting to Postgres, which is open source. I wouldn't necessarily suggest changing anything in Redis, but you can view the contents of it. But I can talk a little bit about what you can do in terms of actually changing things, which is what I got on the next slide. So what you can actually do in Redis, once you get into the Redis CLI, you can get a list first of all the keys. You type keys asterisk, and that'll give you a list of all the keys. You'll see that it stores more than just query results. To be honest, I don't know all those other things, what they are. There's JSON objects that look to be metadata about worksheets. And I've had a really hard time getting a hold of someone at Tableau who can explain all this to me. Someone recently told me there's no one at Tableau anymore who knows how all of this works end to end. They all work on little parts. I don't think that's true. I just need to find the right person. To get more information about your cache server instance, so how much RAM is being used, how many keys, you just type info. And if you want to watch the communication in real time from Tableau's processes toward the cache server, you just type monitor, and it goes into a real-time monitoring mode. That's pretty cool. And I'll just toss out, even though we don't have time to talk about it, that there is a wicked cool command called expire at, which lets you take a given key and set a different expiration than the one that defaults with, which is the default 12 hours. So what we did in this case where we knew we were going to have 20,000 users hitting 7 dashboards is we pre-cached everything. And then we went into Redis and said, hold all those cache items for 7 days. And that way, anybody who straggled in and opened their email and connected the day or two after still got fast response. Of course, the end user can always skip that and go straight back to fresh data by clicking refresh. So this doesn't have any negative impact. For more commands, you can go to redis.io/commands. There's a whole lot of cool stuff in there and probably enough content for another day. But moving on. So cache server. Now we know what the cache server is. Let's talk about pre-caching. So pre-caching is where we go and warm the cache ahead of time. And I thought that since I think we have enough time, we're going to bop out a PowerPoint and we're going to go do a little show and tell. So this is a Tableau server. It's one of ours. It's called the Penguin, and we call it the Penguin because it was the first one at BizStory to run on Linux. And when I open up a dashboard like this, notice it's already cached because I was doing my pre-presentation warm-up. And this dashboard that has loaded here, if I go and open it for the first time, I've warmed the cache, provided that I'm not using row-level security, as we'll discuss later. So that means that if my colleague Timothy or Anna or anybody else on the team goes and opens this dashboard, they get to take advantage of the fact that I've already done the work. Well, I've done the work, I've put in the request, and the Tableau server's already gone through that. Hey, what are we doing? We're making a dashboard. Where's it come from? Let me fire some queries. Okay, and all that work is already done. So just like my first slide instantaneously showed you a picture of our website, this shows you the dashboard instantaneously, which is, as we say in the Northeast, wicked cool. So that cache gets warmed when someone opens the dashboard. So the quick and dirty way, if you know that your boss is going to open a dashboard during her meeting at 2:30, go in at 2 o'clock and open all the tabs and click around a little bit, and you'll basically warm things up for her so that she's got fast performance. That's kind of the quick and dirty way. Another way to do this through the Tableau server UI is to use the subscription feature, which is a pretty common way of doing this. Pretty well known, is I can go and subscribe. Who do I even have on here? Oh, I got Bob the Builder. Awesome. So I can subscribe Bob the Builder to this. Bob doesn't seem to have an email. He's just working with his tools. And so I can subscribe Bob the Builder to this view. And actually, it doesn't even matter if Bob reads this email. Just the process of rendering the dashboard and sending this subscription does warm the cache. So subscriptions are kind of a historic way of warming cache for specific dashboards. So you can do all this sort of out of the box. But then we get into the challenge of dealing with filters. And I have placed that somewhere. If only there were a search. Oh, good. There's a search. Let's say we have filters. What you're doing when you use the subscriptions to cache, or you open this view like this, is you're loading this default view and you're caching this default view. But what about selections for different regions? These are different data sets, and each of these selections misses your cache because these are different results. So each of these result sets can get cached separately. And so your initial load can be fast, but then subsequent interactions could still be slow. So how do we make sure that every one of those potential questions a user could ask are pre-cached and are fast? Okay, so that's what pre-caching is. Here's the process then that we would use for automating that caching. So these are all REST API commands. So first you sign in as the server admin, and you get the list of views for the site. And for each of those views, you use the query view image command on the REST API. And the thing about the query view image command is that it goes and does the whole rendering process end to end, just like an end user. So it hits the whole data pipeline, it populates the cache, and yes, it returns an image of the dashboard, just like doing download PNG, and you can just discard that in your script. As long as you get a successful response, you know that you've warmed the cache for that particular view. So I'll start with this kind of simple example and show you what we've done to do this kind of caching. So this runs the entire data pipeline and warming the cache. So we're going to go over to the terminal here, to the command line, and I'm going to grab my notes. And we're going to run this command, and we call it the Tableau hypercacher. I'm just going to run it as is without any arguments first. And this utility takes as an input a few arguments. The caching mode, which we'll talk about in a second, the server you want to connect to, username, an optional password or a prompt, your site ID, and some other things we'll get to in a bit. Let's start with just a simple example. I've got this site, this Latin American site on my server, and what I want to do is cache it. So what I've told this tool is I want to cache all this content on this server for this site as this server admin user, and I want to run 8 parallel threads. We can spam the server into next year with 1,000 parallel threads if you want. The only limit here is really your laptop's ability to generate load and the server's ability to process it. So paste in my password, and you see it's gone and found all the views that are on that site. It's going to run through with 8 parallel threads and pre-cache every single one of those. What it's pre-caching is the default load. So it's no filters at all, just the default settings. You know how the user, of course, can select different filters ahead of time. That's what we're doing here. So what we've done now is gone through and done 28 views, and each of those views, of course, can have one or more queries, and then those queries, their result sets, all get cached into the cache server and are now available in memory, and the timer is ticking down for the 12 hours that they are sitting there available to users. So all those dashboards will be fast now. Okay. So that runs the data pipeline. Wonderful. You can also do this same thing. I won't even go back into the slide deck because we're going to go right back to another demo. This can also be done with tab command, with tabjolt. Tabjolt actually does something somewhat similar. It does generate several requests per viz, but it does something very similar in terms of its mechanism. Again, subscriptions can do that. There's nothing particularly special about what we've done here, what we've automated, because this is all very easy to do with other tools. The next challenge, though, that we face is scoping. And scoping is about making sure that we impact only the right vizzes. And here I'll just show you the JSON configuration file that we've come up with for this, where we can use a regular expression to capture certain lists of views or users we want to focus this filter effort in on, explicitly include certain views, and explicitly exclude certain views. Just checking to see, by the way, if there are any questions. Is Tableau prep similar to Alteryx? That's been answered. Good. So we can use this then to filter in on a specific set, and I will show you that as well, just since I think we have enough time for that so far. So we're going to scope this down to just a specific set of dashboards. You see that instead of hitting all of these, we'll hit only the ones that match. Grab my credentials, make sure that screen is not showing. So see, now we've only filtered down to just those 3 views, and we've pre-cached just those views. So we can scope down to impact just for specific users or specific sets of views or projects or workbooks. But now row-level security comes into the equation, and this is where it gets fun, really fun. Row-level security in Tableau, as you know, can be implemented with user filters or with the isMemberOf function or initial SQL, with the Tableau server user full, or a variety of other mechanisms. And as soon as you use any of those mechanisms, Tableau shifts from, hey, we can share cache among everybody who has access to this view, to a per user caching mode. So you'll see the number of cache entries go up significantly once you switch to row-level security. And that makes sense. If my colleague Timothy and I if he can see Belgian data and I can see Dutch data in our data set, well, there's no way we could share cache. Tableau has to keep 2 separate sets so that when Timothy accesses cache data, he sees just his data and I see just mine. So the minute you use row-level security, the amount of caching need you have goes way up, because now all those result sets are split out per user. And by the way, if anybody from Tableau is watching this and can comment on whether they intend to implement a group level for this at some point, I would love to know. But for now, my understanding is it's user by user. And you can see this in Redis. The minute you switch a viz to row-level security and go and pre-cache it, the number of cache entries just goes up phenomenally, quite significant. So row-level security, how does that actually impact this? Well, now you have a problem, because if you've signed in as the server admin and gone and pre-cached everything, haha, it doesn't matter, because that cache is worthless for all of your actual users who are trying to access these views. And they're going, hey, you told me you cached it. Why is it still slow? Well, it's still slow because you cached it for the admin and not for the actual users. So now your loop needs to look a little bit different. As you may know, the REST API enables you to impersonate users. So what you do is you sign in as the server admin, you get your users for the site. Then for each user, you impersonate them. There's a method to do that on the REST API where you pass in that user ID. Then when you call get views for site using the token for that impersonated user, the list of views you get is that user's subset. So if you got thousands of views on your server and you run this, you'll get different lists of views each time you call this, depending on what user you're impersonating, which makes sense. So now for each view, for each user, you then run that query view image and you get back a view image that caches. So I will show you what that looks like. And that now warms the cache for each user. As you can imagine, the number of requests goes up pretty steeply here, but just wait, we are just getting started. And I will show you how you can genuinely spam your servers at serious scale to achieve performance. So let's do this now with the cache content per user mode. So you can see I've added this cache content per user instead of just cache content. No filtering on my views at all. So what we're going to do now is pre-cache every view for every user on the server. So now it's going to iterate through each of those users, and then in parallel go and pre-cache all their dashboards. It looks like most of my users on this demo site have access to all the views, and so we end up with a total of 168 view combinations that we have pre-cached. And now the cache is warm for each of those. So initial load for every one of those users is going to be lightning fast, even though I don't have their passwords. Because I had a server admin service account I could use, I could pre-warm everything, which is wicked fun. But wait, it gets better. So now let's talk about filters, because it's not enough just to cache the initial load. It is often the case that the initial load can be fast, but then users start filtering around and things go to crap and it gets slow. So you have to preload certain combinations of filters. So how do we do that? Well, mercifully, the REST API gives us the ability to apply filters. Sadly, not parameters. This is possible through the undocumented client XML API that some of you know about. There's some folks in the community who've done some great work on it. In fact, is out on GitHub, somebody posted a documentation of it that's pretty good. But anyway, there's an undocumented way to pass parameters, but let's stick with what's official. And in the REST API, you can pass filter combinations, not yet parameter combinations. I need to check 2019.1, but I don't think they added that. So what we do then is sign in as server admin, get the list of users. For each user, we do impersonate. Now, for each view, we get the list of filter combinations. And for each filter combination, for each view, for each user, we query the view image. This is basically like a computer science 101 programming course in nested for loops. So we get the view image for each user, now passing in the combinations of filters. And this is where it gets potentially rather interesting. So let's go and look at how we've configured this. So I've got a filter config. I got to drag this panel thingy out the way. I have a filter configuration here, and I have one that just has one filter somewhere. Sorry, thought I had it open. One filter, yes. Okay, so we've scoped this thing down to impact just 3 vises: product, customers, and overview, these 3 sheets. And then we've also defined a filter called region with values central, east, south, and west. Now, one person who looked at this said, why don't you do that dynamically with the REST API? I was speechless and thought, why didn't I think of that? I don't know. It is a great idea, and I haven't gotten to it yet. Sorry, not sorry. So for now, you can control. I could spin it, though, marketing-wise, and say, well, I wanted to give you more fine-grained control over which values you pre-cache. But to be honest, I hadn't thought of it. It's a great idea, and you should do that if you implement something like this. But in this one that we have, it's a manual configuration. So I'm going to say I've got a field called region, and it has values central, east, south, and west. And I want to pre-cache my views for my users for these values. So how do we do that? Well, thankfully, we can just pass in this JSON file directly into our script. So let's see here. We have one filter cached per user. So now we're doing cached content per user. We've added this argument with a filter file, which is our configuration file that includes our scope, so what we want to impact, and then also the filters we want to apply. Just checking time. I think we're okay here. So what you can see now is we've gone out and worked out the combinations of values. So you've got central, east, central and east, central, east, south, east, south. Those of you who took stats or any kind of math courses will remember this. Since we're in Europe, I should say maths courses. So even though we only had 3 views and a handful of users, because we had 4 total values, we ended up with a, I guess you'd call that permutations, combination set of values. And we've now pre-filtered and pre-cached this viz for each user for each set of values. Any questions about this so far? So hard to do these webinars because you can't see if people are falling asleep or totally engaged. So if you have any questions, please feel free to drop in the Q&A panel or the chat, and I'll make sure we answer them. All right, so that's one filter, but actually it gets a little more complicated because it turns out that people often have more than one filter. I don't know why. Some of them like to have tons and tons of filters. So what if you have multiple dimensions that you want to filter by? You've got a year selector, you've got a region selector, you've got a category selector. How do you make sure you pre-filter all the combinations? Well, we provided an ability to create those configurations and put those configurations into the file, and then to specify at runtime how you want to handle those combinations. So let's see here. So the options that we have include individual. So that means each filter is run individually. So let's say we have region and segment and category as filters. It would first run all the combinations of region, then it would do all the combinations of segment, and then all the combinations of category. No combined combinations. The benefit of this is basically it covers caching your initial load and caching the one next action that people do. Because usually you don't have the apply button, usually people don't pause. Usually they go in and just click one filter. And so this will cover you for your initial load plus their first next action. That's usually enough. Now they're hooked, they got some analysis, and hopefully they've now drilled down far enough that their additional filter, their second filter, is fast even if it misses the cache. So we have individual mode. Then we have Cartesian mode, where each filter value is combined once with one value from each other filter. So if we have office supplies, furniture, technology, and we have central, east, southwest, we'd have central with office supplies, east with technology. Then there's an all combinations mode, which is like hyper spam mode, full combinatorics, used with caution, and then a no filter mode. We discovered pretty early on in using this at clients, whoops, too soon, that it yes, can generate tremendous amounts of traffic. And I will illustrate this using Wolfram Alpha because they're much smarter than I am. And yeah, so let's say that you have a list of countries and you're trying to use the hypercacher. And so now it's gotten to the point where it's doing the subsets of countries in the world. That's about 115 countries. It turns out that you generate a tremendous amount of traffic towards your server, a sort of unrealistic and crazy amount of traffic. So what we have done is added some throttling. No individual filter is allowed to be run with more than 256 combinations. So, and that's just a hard limit for now. Eventually we'll externalize that. But so this is best used not when you have filters with large numbers of values. It's best used in that single filter mode. In that case, let's say you have a list of 10,000 products. Yes, it would be lovely to pre-cache every possible combination, but no, it's not worth it. So it's probably worth it to just pre-cache the 10,000 individual selections, not all the combinations. Okay, so there's a little bit of throttling we built in because we found that the combinations mode can crush your server at tremendous scale. There's a question, this is a good question, what effect did this have on memory? I had predicted wrong that actually it would really impact the memory of the server. And so I had, when we were doing this, 20,000 users, 7 dashboards. So you're looking at hundreds of thousands of queries pre-cached. I had anticipated that, and we had raised the memory limit for the cache server instances. The default used to be 512 megs, now it's a gig. And I thought, oh, let's bump that up. And it turns out we didn't get anywhere close to that. And you can get stats. It's in the Redis CLI. You can just get stats on the keys. Oh, and I meant to show as well that there's a really cool web UI for Redis. It requires installing an agent on your box. But this is one of our servers. And let's see, info panel. Yeah, so it has 42 keys currently cached. You can see the keys listed on the left, literal query results and abstract query results. And those 42 keys take up 1.5 megs. So nothing, basically. And by the way, this I don't know if I can recommend officially this Redis monitor, but it's pretty slick and we use it. So yeah, memory impact actually was surprisingly small. The average cache entry, at least in the cases we've looked at so far, the average cache entry is about 2 kilobytes. So that actually makes sense if you think about it, because it is the result set. It's the aggregate results. You might have a billion rows, but you never present a billion data points. You present, a time series down by month, split by some dimension. So unless you have a pie chart with a million slices, this probably won't be a problem for you from a memory perspective. That's a good question. Okay, so filter modes. We've talked about crushing your server and the impact that can have. And then I just thought, as kind of the coup de grace here, I would show you a full-on caching with all combinations, 2 filters, cached per user. So this will be kind of our chef d'oeuvre, so to speak. So for our final act today, we will really properly crush our demo server. We are going to hit it with all combinations of not 1 filter, but 2 filters. So here, we're going to take all the region combinations and all the category combinations, and then all the combinations between those. So central, central east, central south, central west, central east, south, et cetera, with office supplies technology, et cetera, et cetera. So everybody ready to spam this thing into next year? I did actually manage to bring down a server doing this, so use it with caution. But boy, everything was fast when it came back up. And here we go. So now this is for every user on the server, for every view that matches our filter scope, for every possible combination of each dimension, and then each combination of those dimensions, we are pre-caching, pre-rendering the full dashboard end to end. And we're doing this with 8 parallel, but you can do as many as really realistically your load generator and target server can handle. It's also a good way to kill time if you got a couple minutes left at the end of a presentation, just to run this thing. It is kind of beautiful. We might as well tell a story. We had a client last year who was panicked about a go live. They were going to roll out a dashboard with row level security to several thousand users. It wasn't fast, blah, blah, blah. Do you have a solution? We tried to tune the dashboard as much as we possibly could. For various reasons, we could not get it below what was acceptable. I really think we squeezed everything we could out of like traditional Tableau desktop tuning stuff. And so I said, well, I'll tell you what, we do have a little tool in our toolbox for this. And we set it up with one of their server admins with his permission and ran it. And the next morning, one of the other server admins grabbed me and said, what on earth did you do last night? Why? Well, someone generated 260,000 requests to our Tableau server this morning. Was that you? And I said, yes, but it was at 6:30, right? That was like what we agreed. And she said, I wasn't told about this. And I said, oh, sorry. And then I said, is it fast? And she says, it's very, very fast. So I guess sorry, not sorry. And we all kind of agreed to, wink and let it go. And the end users were ecstatic. How did you get it down to a second per load? And I'm like, well, we're wizards. So that's the hypercacher. This is how you aggressively pre-cache with Tableau Server's REST API, spam your server at tremendous scale, and get incredible performance by applying principles from the web. Thank you very much. If you have any questions, you can email them to me or post them in the chat panel, and I'll open it up for Q&A now. I think we have a little bit of time. Oh, hey, Matt Francis is on. Hi, Matt Francis.
Thank you, Matthew. Can you see the Q&A window?
I can. Here we go. Hundreds of users with row-level security. How does the memory management happen with the cache process? Can we increase the cache memory size? Great question. I kind of touched on that a little bit already. The cache server can be adjusted. First of all, you can have multiple cache server instances. Surprisingly, they don't synchronize. I had expected that they would synchronize, and they don't. So actually, what appears to happen is that the VizQL instances have access to a registry of the cache server instances in the cluster, and then they check across them. What has not been explored yet is, in a large cluster, what happens when you have tons of Redis instances? Does that actually slow down the VizQL server as it has to go and check all of them? Why don't they synchronize? Could we write our own synchronization utility? Anyhow, those are still open questions with Tableau, but the memory management with the cache process, Redis automatically discards old cache entries when it runs out of memory. So the default limit is 1 gig. I'll bet none of you have ever touched that limit. I know we haven't in production yet. The 1 gig limit per cache server instance. And the default time to live for each entry is 12 hours. So hundreds of users using row level security. Again, we ran 20,000 users, 7 dashboards, and of course, multiple queries per dashboard, hundreds of thousands of cache entries, and it barely broke a sweat. I think we were at like 100 megs of consumption per cache server instance, something like that. So great question, thank you. Next question is, what effect will this have on memory? Also a fair question, just addressed. Matt Francis, hi Matt, says, this seems like a no-brainer to implement, but I'm wondering if there's a reason to not do this. Well, I mean, there's always these trade-offs, right? We could talk about the green side of it. I actually do think that, generating tons more load like this that just gets discarded, it almost feels kind of criminal and wasteful to spin so many CPU cycles for tens of thousands of requests that will never, ever be used and will just expire in 12 hours. So I don't know, there's a thought maybe there about whether that's really truly a green policy to, generate more heat and burn CPU cycles for nothing. That's one consideration. The other is that, yeah, it does place tremendous load on your server when it's pre-caching. So you'd have to do it at hours that people are not using the server much. And I have only implemented throttling on the number of parallel requests. I haven't put any kind of like wait time. So, for as many threads as you define, it hammers away until it's done. Next question, does this only work with extracted data? For a dashboard that's querying live data, then when someone loads a pre-cached dashboard, the view would be stale. Well, anytime you hit the cache on the Tableau server, your data is stale. That's normal. So anytime somebody else opened the dashboard that morning, but there are some cases where it would not be able to generate the PNG. In fact, the Tableau subscriptions feature doesn't work in cases where there's no way for Tableau to impersonate the user and generate the dashboard as that user. So for example, if credentials are not saved and it always has to prompt, then obviously it can't impersonate you to preload the dashboard. So there are some cases where you can't use this. All right, I'm back. Sorry, I think Zoom kicked me out after 2 hours.
Hi, Matthew.
Which maybe that's my signal to stop talking. If there are any other questions, please shoot me an email or holler in the panel. Otherwise, thank you everyone very much.
Thank you, Matthew. Okay, so next up at 10 o'clock, we're going to hear from Andre, who's going to talk to us about the what, why, and how of Tableau extensions. So if you just give us a few minutes, we'll be back on at 10. Thank you.